So now I want to focus on Syslog. Configuration and verification. How many of you are using Syslog? Anybody here using Syslog? And if you are using Syslog, what are you using it for? Now, Syslog is not a Cisco proprietary feature. It's really a feature, a service, a function we have on many devices throughout the world. Syslog is a way that we can monitor and audit our device. Syslog is a feature that we can use to monitor and audit our device. It's a way that we can keep an eye on the health and well-being of our device. That's right, the health and well-being of our device. You see, when our device experiences an event, what's an event? Well, an event is whenever something changes on our device. Whenever something changes on our device. So, if an interface goes up, if an interface goes down, if a protocol goes up, if a protocol goes down, if somebody's logged into the device when they shouldn't have been logged in, if somebody does this, if somebody does that, so on and so forth, right? This is a way that we can be notified that things are happening on our device. And so, when our device experiences an event, a syslog message is going to be generated to document that particular event. And as Ken said, these syslog messages can feed our SIEM platform. Which is used for what? Monitoring, managing, maintaining our devices, our infrastructure. Ryan says log correlation. Exactly. So I have all these different syslog messages. We can go back and we can correlate events. We can see what caused this to happen, when, where, who, what, why, all that different stuff. So on Cisco devices, what do we have? We have syslog enabled by default. It's on by default. And messages are going to be sent to the console by default. They're going to be sent to the VTY lines by default. They're going to be sent to RAM, also known as buffer, by default. What is the problem with all three of these by default? They are not long-term solutions. None of them. Nope. So, what is a long-term solution? Having a centralized repository somewhere, like a Syslog server, that can collect all those Syslog messages. Why? One, it has more storage, first and foremost. Second, its job is to collect and store Syslog messages at a minimum. And if something happens to my device, do I lose my syslog messages? No, because they're in the syslog server, even though my device is gone. So the console port. How do I see the syslog messages, folks, if they're sent to the console port? I have to be logged in and looking at the screen, don't I? Yep. What about the VTY lines? I have to be remotely connected and looking at the screen. Oh, but there's something else as well. What is the extra thing we have to do if we want to see the log messages that are sent to the VTY lines? So for example, right now on R1, let's type in debug right, so here right now, I'm on the console port. We can see the debug messages. They are a type of syslog message. They're a level 7. More on that later. But there is syslog messages. There are syslog messages. Now let's go over to DSW1 and let's telnet in. Or we're going to have to SSH. All right, so I'm connected to R1. How come I am not seeing those messages? even though it's on by default on the VTY lines. Because I have to tell the device to display it. So although they're being sent, folks, they are not being displayed by default when you're remotely logged in. So it doesn't matter how many times I type in the commands, or for example, even if I type in you all to shut off the debug, so it's off, is it really off? Yeah, it's stopped. It's off. It's done. See over here on R1, officially R1, it's off. Okay, go back to DSW1, debug IP OSPF hello. Again, now look, I'm not seeing anything, but if we go to R1, it's happening. So the command to turn it on, to see it is terminal monitor. How many of you are familiar with that? That's the keyword we're looking for here. Now look, I can see it on the VTY lines. So they're being sent, you just don't see it. So how do you see them? Terminal monitor. And then how do you not see them again? The command is terminal no monitor. Terminal no monitor. Not no terminal monitor, it's terminal no monitor. And then you won't see it anymore. So that is just something to keep in mind. Yeah, so if you're telnetting in, Ken, or you're SSHing in, you're going to have to do that. Now, you can set up your VTY lines to always have this feature turned on when people log in. But for CCNA exam, and even Encore exam, when we talk about our VTY lines, if you're ever asked, you're logged into the VTY lines, you're logged into Telnet, or you're logged into SSH, and you're not seeing Syslog messages, it's because you didn't type in terminal monitor. Because it doesn't show them by default. It's sent, but they're not displayed. Yeah. Ken also said a moment ago, Syslog serves a forensic analysis tool for security events. Absolutely, Ken, as well. Because that Syslog server can collect and correlate all of that information from all of the different devices, and it'll help you do your forensic analysis. Absolutely. Absolutely. Oh, I forgot about one more, and that is RAM. So how do I see it in RAM? You type in show logging. So when you type in show logging, oh, we're on the wrong device. Let's get back to the right device. So over here on R1, if we type in show logging, as you go down, you'll start to see it down here. All right, so the console port is bad because you got to be there to see it. So it's good real time, but it's not good long term, and there's no way to correlate things. Same thing with the VTY lines. Good real time, but not good long term because of correlation issues and different things like that. Shut that off. So not good either. But you might think, well, the buffer, right? That's a storage location. That's in RAM. But it's only 8,192 bytes. And it's RAM, volatile RAM, meaning that if you reboot the device, it's gone. It's gone. It disappears. And so you might, well, we'll increase it then. Well, yeah, but if you increase the amount of RAM that's being used for the buffer, you're taking that RAM away from the rest of the device to do its job potentially, which means you could hurt the device long term. So there's not really a whole lot of space in here to store stuff. So if you notice that we pretty much in the buffer only have those debugs that we were running now. There's your 8,192 bytes. That's not a lot. So it's good for real-time, momentary, collect information, look at it in the buffer. That's it. So that way there, instead of having the console or VTY line show stuff, when messages show up, they go in the buffer, then you can look at them in real time in the buffer, but you still want them shipped to a Syslog server. You don't want them sitting here in the buffer where they could magically disappear on you at any time by being overwritten or completely wiped out because you lost power to your device. It was rebooted, as an example. So here's a message. Example of a message. So we shut down the interface, which causes an event. And so I have 3 messages that were generated because of this one event. We've had EIGRP, neighbor change because of that. we had the interface administratively go down, and then we had the line protocol go down as well. So we went down at layer 1, down at layer 2, and it affected our EIGRP neighborship. So these are all related to each other in some way, shape, or form. So by understanding how to read a syslog message or multitude of syslog messages and put the story together, for example, we would know, oh, EIGRP is down because the interface is down. We know that. But why is the interface down? Oh, because somebody shut it down. So what type of information do I have here? Well, first of all, we have our timestamps, which are really, really important. Do you have to have timestamps? No. You can shut off that feature, which is, of course, not recommended. But if we look at, if we type in configure terminal and then exit, we'll see here, there's our timestamp for our syslog message. Wait a second. Did we change anything here? Let me try this. Look at that. So this brings back a question from a while ago. Notice how the syslog message is UTC no matter how it's displayed. You see that? I'm displaying show clock as Atlantic Standard Time, but my syslog messages are still using UTC behind the scenes. See that? See that? So, how can we, if we want to, so it'd be no service time. Do this every time. There we go. So no service timestamps will shut off time for my log messages. So now notice there's no time. That has no value for me whatsoever, and it should never have any value for you. There's also sequence numbers you can do as well. Which can be beneficial, but the sequence numbers are just the order they were generated in. But that doesn't, again, help you out with time. So time in modern networks is very important. So having your synchronized time with NTP coupled with timestamps on your messages is important. So we'll type in here service timestamps. And in this case, I want my service timestamps for all of my log messages. And I want it to be based on date time, not uptime. Date time, not uptime. So that way there, I actually see the date and time based on NTP. Right now, let's add a little bit to that command because I want to show you that if by chance you want to see your syslog messages in your local time, then you have to use that time zone command. And you also have to go here and type in local time. And now that I've done that, you can see my syslog messages match up with my show clock output. Okay. So, David, as you can see, if I want my syslog messages to be shown, displayed here on my local device in this time, then I can get that done. But see, that time zone command, that summertime command, all of that stuff is for local displaying. Now, in this case, my local time zone for timestamps is now being used for my syslog messages, meaning that that's what would be shipped off. So if your goal is to have your local time displayed in your syslog messages, you got to put on that local time at the end. What else do we have in these messages here? So after your time, we then have what? We have a mnemonic. That's what that's called, a mnemonic. And the, facility. All right, it's the facility is what I meant to say. The facility, which is referring to the service or the function, the feature, whatever it was that triggered the message. So that is the facility that triggered the message. So dual meaning EIGRP, link meaning layer 1, line protocol meaning layer 2. Right? So if it was some other system we have, oops, wrong button. If it was some other message we had, could be the system or OSPF or security or dynamic ARP inspection or DHCP or an SSH message and so on and so forth. And then after that, we have the severity level. I'll talk about the severity level momentarily. Then we have the mnemonic. That's where the mnemonic is. Essentially, it's a device-specific code that uniquely identifies the message. So this is a neighbor change for EIGRP, or layer 1 changed, or layer 2 went up, down. And then we have our message after that, which explains in more detail what has happened. So the severity levels are extremely important because they identify the criticality of the actual message, how severe it is. Should you memorize this? Sure. Yes, please. Please do. A while back, I had a student named Brian. Brian came up with this. Chat area. Every awesome Cisco engineer will need ice cream daily. Every awesome Cisco engineer will need ice cream daily. There you go. If that works for you, awesome. And then it's 0, 1, 2, 3, 4, 5, 6, 7. What else do I want you to remember? This is bad. This is good, essentially. Meaning, it gets better as you go up. It gets better as you go up. The severity level. So the higher the number, the better it is. Now, I'm not saying debugs are great, because debugs, if used incorrectly, will crash your machine because they can overwhelm the CPU. But a debug is a way that we can get real-time information of things that is happening right now on our device. And you use that typically when you are you're at your last resort and you really don't know what's going on and none of the show commands are giving you what you need and you're on the phone with Cisco TAC and they ask you to do some debug commands. But hey, if you want to use debug commands whenever you want, go ahead. Just be mindful that you could crash your device because they are very resource intensive. Now, these severity levels. In the real world, I encourage all of you to take them with a grain of salt. Let's put it that way. Now, Ken, it appears like you have a lot of experience with Syslog. And I'm going to ask your opinion on this then. Do you find that some of the messages that are generated, the severity level doesn't actually equate to the true production level severity that you would hope it would provide you? Like, for example, EIGRP or a link going up and down. Really? Really? Just a notification? Just a notification? Really? Right. But, and what can happen? Well, if you have a really robust Syslog system and you have programmed that server to text you or email you or send you a message, if all of a sudden there's a bunch of level 3 messages, well, then you're never going to get a message about this then. You're not going to be notified about that. So don't use these as the deciding factor as to how you are going to progress based on messages you get. Because that is not going to work out for you in the end. So I do find, like, for example, here, A lot of these are just in the informational and notification range, but some of these are pretty severe in an environment where I'd want to take a look at them right away, not 3 hours from now. Do I need you to memorize these for this exam? No, I don't. But know the order, as I mentioned. What would be more severe than something else? And what name potentially goes with what number can help you out? Also, this was taken on a Cisco iOS router, 2900 series. This was taken off of a Cisco CSR 1000 virtual router. Notice how the link on that device has a severity level of 3, but on this device it has a severity level of 5. Really? Really? So even cross-platform, the severity level numbers might not actually be the same. Oh, Ken, is that what you just typed in? Is that what you just typed in? Yeah, I think so. So the severity level is different depending on devices and different things. So keep that in mind too. So when it comes to the exam, yes, you got to know this, okay? Even if it's just for 1 or 2 questions out of 100 questions, it's worth knowing so you can walk away knowing that you were successful. And down here, I even have the note when you're reviewing with the slides, if you want to, about if you're using Telnet or SSH and you've connected to a device using the VTY lines, you have to type in terminal monitor if you want to see those messages. Now let's go out to our device and just take a look at the output of show logging. So if you're ever asked, how do you check the configuration of Syslog on your device? Show logging. Now when we're here, you can see it's enabled by default. Console logging, so to the console port, it's level debugging. What does level debugging mean? Okay, this is what it means. It means level 7, 6, 5, 4, 3, 2, 1, 0. It means all levels. So it means that level and everything lower. So if I type in here, logging console, we can change the severity level. So let's say we change it to a severity level of 6. Now we go back and we type in do show logging. You'll see here it says informational. So informational will be 6, 5, 4, 3, 2, 1, 0. So the same thing with monitor logging. Notice it is debug, meaning 765432110. But if you want to change that, we can change it by typing in logging monitor. So monitor is for the VTY lines. Terminal monitor to see them. Logging monitor, the VTY lines. And again, I can change the severity level. So let's say we picked 4 in this case. So 4 is warnings. So if I showed you show logging, warnings is level 4. So is it just level warnings? No, it's warnings, errors, critical, alerts, emergencies. So it's 4, 3, 2, 1, 0. Now when it comes to the buffer, our buffer, we're going to have the option of setting the actual severity level that's sent to the buffer. But we also have the ability to set our buffer size. So right now it's 8,192 on this platform. I have other platforms that's only like 4,000 something. I have other platforms that's higher. But the key here is to realize that if you ever change this buffer size from its default, anything that's in the buffers, delete it. It starts scratch. It starts from fresh. So if there's anything in there that you need to preserve, get it out of there first. Copy, paste it out, put it somewhere else. So here, I'm going to type in logging buffer, and we'll change our buffer to something like, let's just do 10,000 right now. And then when we type in do show logging, we'll see that our buffer has changed size. It is now 10,000, but notice there's no messages in it anymore, except for this one new message stating, hey, you changed your size. So you can change the size, and you can also change the severity level for that one. And so lastly now, let's talk about our Syslog server. So we would have a Syslog server set up somewhere in our organization. And you can see down here, by default, there is nothing set up to send the data to the Syslog server. So what we would do is we set logging. The command is logging logging host first for the IP address I want to do. So what is my Syslog server's IP address? So whatever that happens to be. So we could type in, for example, let's say it's 10.0.5.9. Now, let's not forget that we can set up the source. So logging source interface loopback 192. So remember we set up that loopback interface in our NTP discussion. Well, now I can make sure that every time I send a message to a Syslog server, it's coming from my loopback IP address of 192.168.255.2, or 1, I mean. Now, why would I want to do that? So that way they're on my Syslog server, I could set up features like firewall features, access control list, whatever that particular Syslog server has built into it, I can go in there and set up an allow list and saying, only accept Syslog messages from this device, this based on the IP address. And so since no matter what, this device is always sending from that IP, I only have to reference that one IP for this entire device, regardless of the interface it's sent out of. Because how do routers figure out the source IP of packets they send? They put the exiting interface's IP address. So if the router says, hey, I'm building a packet to send to the Syslog server, based on my routing table, which way do I go to get there? Oh, I got to go that way. What's the IP of my interface? It puts it in there. But now instead, with this command, it's going to do what? It's going to put that IP address in it no matter what and send it out whatever interface. And then let's not forget about being able to set the severity level. So in this case, it's logging trap. Okay, so logging host to set the IP, source interface to set the loop source interface, and then trap to set the severity level. So I'm just going to put it as 3 just as an example. What you choose to do for severity levels in your own life is your choice. So there's not going to be any questions on the exam that say, based on Cisco recommended best practices, what should you... No, you don't have to worry about any of that. So now you can see for logging trap, we're sending it to 10.0.5.9, UDP port 514. Maybe that's another good port number to know down the road as you are preparing for the exam. UDP port 514. And then there's our logging source interface of loopback 192.